let's do example problem 12 on page 87. And here it is. And I'll zoom in a little bit. And it says, two boxes are connected by a cord, A and B. And they're connected by a lightweight cord and are resting on a smooth, frictionless table. Frictionless table, like an air hockey table or something like that. The two boxes have masses of 12 kilograms and 10 kilograms. A horizontal force, FP, of 40 newtons is applied to the 10 kilogram box, as shown in figure 422. And there's figure 422. Find the acceleration of each box and the tension in the cord connecting the boxes. Okay, so let's do that. And let's do it using the procedure. Step 1, given. Find and solve. Let's draw a picture of the problem. Here's a frictionless surface. And I'm looking at the book this is box B, actually. And it has a mass of 12 kilograms.
Oh, Mr. Levin can't see.
Oh, thank you. Thank you. I forgot to zoom back out. And then connected to it is box A. Oh, I drew it bigger, but it's actually a smaller box, or less massive box. 10 kilograms. And someone's pulling on it with an applied force here, or pulling force they call it, of 40 newtons. And so that's all we know. And so what are we trying to find? Well, for part A, it says find the acceleration of each box. Well, the boxes are tied together, right? Unless this string that's attaching them is going to stretch or something, they're going to accelerate together. So I'm just going to say the acceleration of A and B by inspection, by looking at the problem, it's just going to be one single acceleration. And then for part B, it says find the tension in the cord connecting the boxes. So I want the tension force, I'll call that F sub T. T for tension. Let's find that tension force. Given, find, solve. So I just did step 1. Now, step 2 is to draw the free body diagram. Well, now this one's a little tricky because I've got a choice. I could draw the free body diagram of B or A and B together. Now, because they are connected and I just want the overall acceleration, I'm going to draw the free body diagram like this. There's my free body. And I've got the mass of B. Oh, well, you know what I'll do instead of that? The force of gravity on B. The force of gravity on A. Here I've got the normal force on B. And the normal force on A. But most importantly, I've got this pulling force, 40 newtons, like that. And, well, they called this F sub P for pulling force. I usually call it F sub A for applied force or whatever. That's okay. I've just drawn the free body diagram, and that is step 2. I have finished with step 2. So, given, find, and solve all this. This is step 1. And drawing the free body diagram, this is step 2. Now step 3, well, let's make this the X direction. Let's make this the Y direction. Now the nice thing here is that I don't have to break these forces up into their X and Y components. They're already lined up with the X and Y direction. So I'm done. This right here is step 3. Now, the critical step, step 4, using Newton's second law. Let's sum the forces in the X direction equals MA in the X direction. Boom, let's do it. Well, if I look in the X direction, let's sum the forces. Well, I've got a 40 Newton force like this. And that's it. If this is my free body diagram right here, there is one and only one force acting in the X direction. That's that 40 Newton force. Now later on we're going to do friction. And friction will make this much more complicated. But this is an easy problem now. Because this is equal to MA. And A is what I'm trying to find. But here's the question. Here's the big question, the key idea behind this problem. What is the mass? Well, let's solve for acceleration. Acceleration is going to be equal to 40 newtons divided by the mass. But what is the mass? I'm sure they can't hear it at home, but there was a goofy noise there. Stop squeaking. All right. What is the mass of this system? Well, this is the mass of everything that's being accelerated in my free body diagram. And all of it is being accelerated. This whole thing is being accelerated with this force. So how much mass is there? Well, 10 kilograms plus 12 kilograms is 22 kilograms. And now I can solve for my unknown. Now this is step 4. This is step 5. So this was step 4. And this is step 5. And step 5 is just using your awesome algebra skills. And you get 1.82 meters per second squared. That's the answer. They're going to accelerate together because they're tied together, and they're going to have that acceleration. Now, what about part B? We want to know what is the tension force in here. And this is a little tricky. I'm going to start over again, and I'm going to just draw a free body diagram of B. And you'll see why in a second. Why not A? I could do A. I could do A. But I'm not going to do A. I'll just do B. And I'm going to draw a free body diagram of it. What I got? I got, I keep doing that. I don't mean to. I have the force of gravity acting on B. And I got the normal force of B. And I got this tension force. Oops. This little tension force. And that's it. Well, you might say, well, what about the 40 newtons over here? This 40 newtons is not attached to B. It's attached to A. That's why I chose to draw a free body diagram of B. Make it easier. Because I know if I just look at this guy, just look at this, don't look at anything else, just look at B. Don't look, just look at B. You've got gravity pulling it down, you got the normal force pushing it up, and you got that tension force, that string pulling it to the right. That's it. It doesn't know about that, 40 newtons. So now I'm going to sum the forces in the x direction equals ma in the x direction. I'm running out of time, so I'm kind of rushing through this. We'll do this. Sum the forces in the x direction. Well, there's only one, the tension force, equals ma. Well, guess what? I know what m is. I picked object B, so that's 12 kilograms. Do I know what the acceleration is? Yeah, I solved for it in part A. The acceleration of the system is 1.82 meters per second squared. That is the acceleration of of crate B. Are you getting this? Okay, don't drift away. Class is almost over. Wait, 82 meters per second squared. And now the tension force in that string must be, well, 12 times 1.82 equals, and you get 21.8 if you round off newtons. Now, I leave it to you, because we're running out of time. I leave it to you, but try this. Draw a free body diagram of A and see if you get the same tension force. You will. You will if you do it right. All right. That is all the time we have for now. So that is all.